Hello again. So today we're going to talk about, this is lesson 6.7, and we're going to talk about something called error, and then also something called power in a hypothesis test. Our objectives today to define type 1 and type 2 errors in context and define power in context. So in hypothesis tests, what we learned up to now is that we make decisions about a hypothesis test based on a probability, the p-value. So if the probability is really small, then we say, maybe the null hypothesis isn't actually true because it would have been really unlikely to get this thing that we got if the null hypothesis were true. If the probability is not too small, then we say, okay, well, maybe the null hypothesis is still really true, but it's all based on a probability. And we know in life that even when something is really, really, really unlikely, that doesn't mean it can't ever happen. Occasionally, that thing could just happen. That thing that had a really small probability, that could have just happened by chance, and we were wrong to reject the null hypothesis. So if we make a mistake in a hypothesis test, that's not because we did math wrong. We call this an error, right? An error just means our probability led us in the wrong direction. This was just truly an unlucky or weird situation, and it wasn't something that should have casted doubt. So when we perform a hypothesis test, we could either reject the null hypothesis or fail to reject. This is based on a probability. This is based on our evidence. In real life, though, the null hypothesis is either going to be true or it's going to be false. And this is the thing that we don't actually know ahead of time. So this is just what's true in reality. Okay. So if in a situation we reject the null hypothesis, but it turns out, we later find out that in real life the null hypothesis was actually true, right? Then we call that a type 1 error. Again, this is not something that we did wrong. It's just that our probability, our evidence kind of led us in the wrong direction. So we make a type 1 error. The probability of a type 1 error is represented by the symbol alpha. And you may remember we use alpha to represent the level of significance. And that is in fact the same value. The level of significance is also the probability of a type 1 error. The other type of error we could make is if we fail to reject the null hypothesis. If we basically say, I don't have enough evidence to say that the null isn't true, I'm failing to reject the null. But it turns out in real life, the null hypothesis was actually false. Like we should have rejected it and gone with the alternate, but our probability led us in the wrong direction. Our evidence led us in the wrong direction. That is called a type 2 error. And the symbol that we use to represent the probability of a type 2 error is beta, which is another Greek letter, alpha, beta, AB, first, second. The other two places are not errors. These are correct decisions. This is when we reject the null and the null is false. So we're good. We made the right choice. We went with the alternate and the alternate was true. Everything's happy. The other place where we can make a correct decision is if we fail to reject the null and it turns out in real life the null was true. So we should have stuck with the null and everything's good. Most of the time in a hypothesis test, one of these two things will happen. We will make the correct decision based on the evidence, and the evidence will lead us in the right direction. But sometimes one of these errors happen, and we have to kind of deal with that and realize that that's a possibility in every hypothesis test that we do, and kind of plan ahead for that, think ahead, make sure that we're okay with that as an outcome, because it will happen. So let's kind of practice this idea of errors and describing them in a context of a situation. So if we consider a test for a serious disease, so our hypotheses, our hypothesis statements for a test for a serious disease, we're going to put them more in words than in symbols because we don't really have symbols to use right now. But just for the sake of this example, our null hypothesis would be that the person is healthy, everything's cool, everything's fine, nothing's wrong, person is good. And then our alternate would be that the person is not healthy or that they have the disease. So our null is everything's okay, nothing's changed, everything's good. Alternate is that something is wrong. Person has the disease, they're not healthy. So in this case, a type 1 error, when we reject the null hypothesis, but actually the null was true, right? We rejected the null, but we shouldn't have, is when we decide based on our test, based on our evidence, that the person has the disease. We reject the null and say, we have evidence that the person is not healthy, that they have the disease, but in reality, they're actually healthy. And we decide that they're sick, but they're actually healthy, they're fine. A consequence of that error in this situation would be that we scare them for no reason. They unnecessarily go in for further testing or maybe even take some treatment that they didn't actually need and could maybe affect them in other ways. Right? So that would be a type 1 error. We think something's wrong with them, but they're actually fine. A type 2 error in this situation is when we fail to reject the null. In this case, that would basically mean I don't have evidence to say they're sick, so I'm just going to say they're healthy. They're probably fine. But in reality, the null was false, meaning the alternate was true. So we said they're healthy based on the evidence, based on the probability, based on the tests. But in reality, they actually do have the disease. And in that case, right, our consequence is we think they're healthy, so we don't give them treatment. We don't give them further testing. We don't tell them they have this disease and they don't do anything about it and they don't get treatment. And that could be potentially really scary. Right? So that's an example of a type 1 and type 2. Another way to think about it in terms of just a quicker way to remember it, type 1 error is kind of like a false positive. We think they have the disease, but they actually don't. So, in terms of like medical tests, false positive is a good way to think about it. Type 2 error is kind of like a false negative. We think they're fine, but they actually have the disease. So, false negative is a type 2 error. Again, this works really well in things like medical tests when we're testing for a specific condition or disease or whatever. I would try not to just memorize type 1 and type 2 as these words because it's not always easy to tell in a given situation what positive means. And so false positive could feel the opposite of what it should actually be for type 1. So this works really well for like medical test type stuff, but try to make sure you're remembering type 1 and type 2 as type 1 reject the null and we're wrong. Type 2 is fail to reject the null and we're wrong. And we'll look at some other examples. But I also like to put these images up there because it's funny. So type 1, he says, you're pregnant. I think you have this condition. Clearly, he does not. That is an error. Type 2, you're fine. You're not pregnant. Everything's cool. And clearly something's going on here. So that is a really funny example of type 1 and type 2. Okay, so let's look at an example that's a little bit more detailed. So a potato chip producer and its main supplier agree that each shipment of potatoes must meet certain quality standards. If the producer determines that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load of potatoes from the supplier. Otherwise, the entire truckload will be used to make potato chips. To make the decision, a supervisor will inspect a random sample of potatoes from the shipment. So they're not going to look at all the potatoes, that would take way too long. He's going to take a sample and make a decision about the entire truck based on this sample. So because he's basing it on a sample, we realize there's a possibility that he makes the wrong decision. He could make the decision that based on this sample, more than 8% of the potatoes in the truck have blemishes, but he could be wrong, or the opposite could be true. So there is potential for error because he's not looking at the entire population. That's kind of the risk that we take. So our hypothesis statements, right, our null is that everything's good. In this case, P is equal to 0.08. Only 8% of the potatoes have blemishes, maybe even less. Potatoes are mostly fine. Everything's good. That would be our null hypothesis, right? Our null in any situation is always everything stayed the same, everything's good, no big deal. Our alternate would be what he's trying to see. Do more than 8% of the potatoes have blemishes? So P is greater than 0.08, means more than 8% have blemishes, so the potatoes are sketchy as a whole. So in this situation, there's my null and alternate again. Type 1, right? Pause, think about it for a second. Okay, type 1 in this case would be we reject the null, meaning we say, I have evidence that more than 8% of the potatoes are bad. But really, the null was true, and really only 8% were blemished. Most of them were fine. So we thought it was more than 8%, so we said, let's send these send these potatoes back to the supplier. They're no good. I don't want them. But actually, they were mostly fine, and we could have used them, right? So type 2 error would be the opposite, right? In the type 2 error, we fail to reject the null, meaning we pretty much decide the potatoes are mostly fine, only 8% are blemished, or I don't have evidence to think that it's more than 8%. But in reality, the null was false and our alternate was true. So we thought they were mostly okay, but in reality, there were too many that were blemished. There were more than 8%. So we thought they were fine, but they're actually not good. So type 1 generally is we think something's wrong or we think something's different, but actually everything's cool, everything's the same, nothing's changed. Type 2 is we think everything's fine, we think things have stayed the same, but actually they've changed. It's kind of a good way to remember it. Which error is worse? So in our potato chip example, there's not necessarily going to be one answer to that question because it depends on the situation. So in our potato chip example, a type 2 error may be worse for the potato chip producer because it may lead to lower quality chips. So if they say, oh, these potatoes are probably fine, based on my probability, based on the evidence from my sample, I think these potatoes are fine, so I will accept the shipment and use them to make potato chips. But in reality, they weren't fine. More than 8% were blemished, and now I have not very good potatoes to make potato chips from. So that might lead to lower quality chips, decreased sales, they're losing money. In that same example, for the supplier or farmer, a type 1 error may seem more serious, right? Because that's when the potato chip company is saying, these potatoes are bad, more than 8% are blemished, I don't want them, send them back. But in reality, they were fine. So they're kind of losing out on a chance to make money. They probably won't throw away the potatoes, but they've kind of gone through a lot of trouble and are now dealing with not being able to sell potatoes that were fine. So it depends on the situation in reality. So one thing to know about type 1 and type 2 error, came back to this image, is that if I decide in a particular situation that a type 1 error is worse, and I decide I want to make that smaller because I don't want a type 1 error to happen, so I'm going to lower my level of significance because I have control over that. And if I do that, what's going to happen by default is that type 2 error is going to get bigger. So when type 1 gets smaller, by default, type 2 gets bigger automatically. The opposite is also true. If I decide type 2 error is not good in this situation, I really want to avoid it as much as I can. So I decide to change things to make that type 2 error as small as possible. Well, by default, that's going to make type 1 error bigger. So they do kind of act in inverse of each other. Real quick, type 1, type 2, alpha, beta don't add to any specific number. There's not a rule for that, but they do act in inverse of each other. So if one goes up, the other goes down, and vice versa. So they're kind of like reacting to each other in a sense. So that brings us to something called power. Power is a word we use when we are talking about the evidence we have and wanting to make sure we make a good choice. So, thinking about a criminal trial. Right, in a criminal trial, let's say you are the prosecutor, you are trying to prove that the defendant is guilty. Okay, and you know they're guilty. Like, you know, with the bottom of your heart, you know that they are guilty. Your job as the prosecutor is to provide evidence because you're not the one sending them to jail, right? You are presenting evidence and the jury's going to decide. So our null in that situation would be that the defendant is innocent because that is how our justice system works in America, is innocent until proven guilty. So the null is that the defendant is innocent. The alternate that we're trying to prove is that they are guilty. So in order to convict the criminal that you know is guilty, to reject the null hypothesis based on the evidence, you need lots and lots of really good evidence. You need power, is what we call that. So without that, we're risking a type 2 error where the jury decides they're fine when they're actually not. So that evidence that we're talking about in hypothesis testing is called power. The strength of our evidence in a given situation is called power. So power, by definition, is the idea that given knowing that our alternate is actually true, power is the probability that our hypothesis test will conclude the alternate to be true. So knowing that our alternate is true in a situation where for sure HA is true, power is the probability that our hypothesis test will conclude it to be true. Numerically, power is just equal to 1 minus beta, 1 minus the probability of a type 2 error, because they're kind of basically the opposite of each other. Um, so in our little table that we had at the beginning, power exists kind of right here. It's the probability that when the alternate is true, we will reject the null and say the alternate is true. So that's kind of where we're at in terms of that little table. Okay. So where power comes in handy in statistics is if we have an alternate that we know is true, and this comes up a lot in medical testing. We have this new medicine, we know it works better because we developed it to work better. We know it's good, but we still have to have our like tests and procedures and evidence prove that it's better. In that case, we want power to be as big as possible. We want power to be really, really big so that we know or have a better idea that our hypothesis test, that our evidence will actually show it to be true when we know it's true. Um, so there are three ways that we can increase power in a hypothesis test. One way is to increase alpha. So the way this works is that increasing alpha, remember alpha and beta, which is type 1 and type 2, act in opposite of each other. So if alpha is going up, beta or type 2 is going down. And remember, power is 1 minus beta. So if beta is going down, power is going up. So they all kind of like affect each other in that way. I couldn't think of that word. But something to keep in mind is that's also going to increase the probability of type 1. So increasing alpha will automatically make type 1 go up. Um, and it's not ideal if you are not quite sure whether the alternate is true. So this would not necessarily be a good situation if we thought a type 1 error is still possible. Another way to increase power is kind of a big fix for anything in statistics is increasing sample size, right? And increasing sample size is going to make our sampling distribution lower, which would then lower probability of type 2, which increases power. Our errors in a hypothesis test, and at some point I may visualize this for you or point you to kind of a good visualization of it, but the errors exist in the tails of that normal model. So anytime we're increasing sample size and narrowing our distribution, it's going to make those tail areas smaller. But taking a bigger sample size in real life is not always possible or realistic. It costs more money, takes more time. It's not always in the budget or in the frame of reference. So increasing sample size is a great fix for all things statistics, but it's not always realistic. The last thing, and this is the weirdest one to kind of imagine, but the last thing is to increase what we call effect size. Increasing effect size basically just means let's make the new thing that we think is better, make it really better, like by a lot. Um, so if we're trying to prove that this new medicine is better than the old one, then if we make sure that our new medicine is way better, like that there's a huge difference between the null and what is actually true, then it'll be really easy to prove that it's true. Lowers both types of errors in essence, or definitely lowers type 2. We kind of control type 1, but it lowers error and increases power. It's not really something that statisticians have any control over, right? If we're the ones doing the test for a company that wants us to do a test, we could tell them, hey, just FYI, the best way for this to work out in your favor is to make sure that your new thing works really, really well. And they're like, okay, cool. So there is a link. I'm going to kind of post it in the comments of this video. There's a crash course video that explores the topics of error and power and how to increase power. And it has some really good visualizations for like how all of that works together. So if you are interested in more about how these things work, or if you just need more explanation, this is a great video to kind of refer to or look at in this topic. So that is the end of this lesson. So I will see y'all next time.